try playlist. Um, so in this problem, we are given this word dictionary, add word, search methods. We need to implement them. So when given this one, we're adding everything, and whatever that thing it's searching, we can search all those things. Only one complex thing here that we have, it's this dots right here. So we have implemented try before. It is it's actually exactly the same code. So I didn't bother to uh, just write that boilerplate code again. So if you watch the previous implementation of try, that's where it is. So what we are doing, we are creating try node class, and in our word dictionary we are implementing that, and in our constructor we are initializing it, and then we did the implementation of add word. um, Basically for each character we are adding it to our children, and then in the end we are marking it as word, meaning that this is the end of this word and this is actual a whole word. And then when we came for search, it is exactly the same implementation that we did it in previously. However, in here I'm just using a helper method, so the rest is just the same. We are searching through it, and if it doesn't contain in our key, we're just returning false. We're grabbing next node, and in the end we're just checking if it's a whole word with this one or not. Now let's take care, the only part where it's tricky in this one is just this dot right here. So now let's take care of it. So when it is not in our children hash map, like that, when it's searching for that, it's not in there. So how are we going to do that? We will be traversing the whole tree by calling it recursively. So why what do I mean by that? So let's actually see the implementation of it. So when it is not in our key, let's check if this given character equals to our dot. If so, let's dive into its implementation. So for each of these character that we are going to see, so car, ch, in our word, we can actually get from our key set, from our node, children, get, so just key set. So all this key set in our children is the one where we are adding everything. So for each of these character, what we are going to do, let's say it's like in case of this B right here, or in case of this right here, so we'll be searching for AD, or in case of here, so we'll be searching for B, so I put this, so we'll be calling the word and then searching for this possibility if we have it or not. So in our key set, we grab the character, and for each character, that's what we are doing it. So we are checking, basically, it's like in worst case, if it happened to be Z in the end, or dot 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 dot, and then the end Z, then we will need to go every single of them. So 26 to power of the size of this word. So try node, child. So we'll be grabbing this child from our map. We get C. So this is our child. So what are we doing? We will be passing this information to our search helper along with this word and substring given I plus 1. So we'll be passing the new word in here and then search for it. So if it actually becomes true, then we'll return true from here. So let's run our code. Null pointer exception. No children contains key. Oh, this is ch we have implemented. Okay, perfect. So let's submit it. So time complexity in here for add word, it is O of n, where n is the length of this word. We're using adding it to our hash map, so it's also O of n, where n is all those characters in our word. So for search, however, we have this complexity in here. So in case where we receive that, so in worst case, it is O of n times 26 to power of m. So where n is the length of this word and m is the length of the word that we're searching for. So it is 26 because for each step we have, in worst case, we have 26 options to go through, 26 routes to go through, because like I said 26 in English it is at 26 letters in there.